around the pipe circumference, or runs, were welded manually with the remaining filling and capping runs done automatically. This technique proved to be a project success, especially on the heavier wall sections, resulting in quicker joint completion, improved quality and less welder fatigue.
We've been very, very pleased with the performance of this hybrid system. It's given us great flexibility and the quality has been very, very high. Repair rates have been less than 2%.
With the ditching teams progressing north, padding and backfilling followed on quickly behind. To protect the pipe's coating, it was bedded and surrounded with fine material from the excavated trench soil. The most efficient and cost-effective method was to use an Aussie padder to sieve and riddle the trench soil before depositing it directly onto the trench bottom or the ditched pipe. However, in areas of rock, sand or fines had to be imported to pad the pipe. Once padded, the pipe was then backfilled with the remaining trench soil. The material was laid and compacted in layers to avoid settlement at a later date and to ensure all excavated materials were reused. Tunnelling under the River Dee had been completed successfully. On the north bank, steel pipes were then threaded back through the concrete shaft. On the south bank, installation of the vertical riser would be a crucial operation. Being 20 metres high and weighing 12 tonnes, the riser required a bespoke lifting attachment to be designed and welded to it in order to lift and lower it safely. On Saturday the 25th of September, a heavy lift crane successfully lowered the riser into position. It was then carefully welded in place, the shaft backfilled and the riser tied in to the main line. The crossing of the River Dee presented a substantial engineering and environmental challenge to National Grid Transco. A combination of advanced planning, thorough consultation and close teamwork got the job done. The pipeline had to be constructed to meet national and international industry codes and standards. To help achieve this, NGT employed a team of approved inspectors to carry out inspections and tests throughout the construction operations. This rigorous culture of inspection and testing, together with detailed management, ensured that the design intent was carried through to construction and that National Grid Transco's quality standards remain among the highest in the world. Post-construction drainage was installed to speed the recovery of the land. It replaced any existing drainage schemes that had been damaged during construction and was installed after subsoil regrading but prior to topsoil reinstatement. Mainline operations were now approaching the northern end. Further south, the all-important process of reinstatement was well underway. The ground was for subsoil to help drainage and reduce the compaction caused by heavy traffic. Excavators and bulldozers then pushed the topsoil back over the backfilled trench and across the right-of-way, leaving the land in a suitable condition for cultivation. The pipeline was designed to last for 40 years. To achieve this, a cathodic protection system using an impressed current was installed to combat the effects of corrosion. 3 ground bed sites utilising vertically installed anodes were built along the pipeline route and a DC voltage applied to the pipeline via transformer rectifiers. Cathodic protection test posts were installed at every road, rail and river crossing to enable future maintenance and to ensure corrosion control was effective. Prior to commissioning, the pipeline had to be tested. Due to its length and the undulating topography, the pipeline was split into 22 test sections. Each section was first cleaned and gauged by a series of pig runs. The sections were then filled with water. Once the ground and water temperatures had stabilised, the section was subjected to a pressure test. Only when the pressure had held for 24 hours was the pipeline deemed to have successfully passed its high-level integrity test. With all the sections successfully tested, they were then welded together into one complete length. A caliper pig run confirmed the pipeline geometry before super dry air was used to remove any moisture within the pipeline. The dry pipeline was then welded into the existing pipeline system ready for commissioning. Stringent checks were made to ensure all NGT procedures and specifications had been complied with before senior managers signed the forms and certificates to state the pipeline was fit to be commissioned. Gas was introduced at Lochside under a non-routine operation carried out by the local operations department. A series of valves are opened sending gas from Lochside up to the Garlogie compressor station, where a silenced vent stack was erected to expel the displaced air. The vented air rapidly became pure gas. Upon confirmation of 100% gas, the vent valves were closed and the pipeline allowed to slowly pressurise to line pressure. When this stage was reached, all necessary valves were opened and the pipeline was considered in service. On November the 4th, 2004, National Grid Transco's feeder 24 gas pipeline from Aberdeen to Lochside was successfully commissioned. What began life as a simple 5-page document back in 2002 had become a £50 million, 50-kilometre testament to our commitment to meet the needs of our customers. Although facing tough environmental constraints and numerous engineering challenges, NGT's expertise and dedication overcame a tight schedule to get the job done, swiftly and safely.
The successful construction of this 50-kilometre, 48-inch pipeline in Aberdeenshire in a single 6-month construction season has been a major achievement for National Grid Transco.